Hello and welcome to Lesson 6 of the UNIDO SPX program. In this lesson, we will deal with preliminary actions, providing basic tools to improve competitiveness. This lesson is part of the series to help you to improve your competitiveness, your capacity, and the capability of your business. In this particular lesson, we will deal with process mapping, a way to let you see your processes, to understand how you are doing things, and to understand where you may have opportunities to improve. We will also deal with physical flow mapping. Once again, this helps you and your people to see the movements of materials and information throughout your business. These two tools are part of the 5 basic tools of improvement that UNIDO SPX are providing to you and your people. The process flow helps you and your people see what are you doing, to see the movements, to understand the opportunities, and to potentially see the areas where you can improve your processes, to increase your capacity, to improve your competitiveness. In the lesson 2, we will deal with physical flows. How are the movements of people, of materials, components, information moving through your business? These are 2 of the 5 basic tools, and there are 3 additional tools which will be addressed in following lessons. The first of those tools will be check sheets, providing you with a mechanism to identify and capture what is going wrong, so that you can find ways to improve it and stop things going wrong. In the further lessons, we will deal with run charts, providing a simple mechanism to let you and your people see, is your process getting better? Are you making improvements? Are you not making improvements? And we'll also deal with people, how to release the power of your people so that you can find ways to improve your businesses together. The first step is process mapping. Process mapping helps us to see our processes. We will deal with this in some detail. It allows us to see what are you doing. It seems very simple again to say this, but in actual fact it can be difficult for managers and people working in a business to see what is actually going on. It's important to capture the reality of what is going on, how your staff, your people, your workers are doing their jobs, and to avoid capturing the perception. We do not need to see the perception, we need to see the reality. Process mapping gives us the tool and the technique to allow us to capture this. As a small example, we will deal with a perception versus a reality in a later slide. If we don't understand the reality of our processes, we will not be able to improve our actual processes. We run the risk of maybe fixing something that isn't broken. We run the risk of wasting time trying to fix perceptions which do not relate to the realities. So it's important that we capture the true state of the operation. We are going to look at a small example of a company that makes windows and doors using timber, using wood. The process mapping starts with a piece of paper. And on the piece of paper, the people are asked to write down the things that they do. What is involved to make a door? What is involved to make a window? And this process starts with taking the timber, the wood, from the stores and moving it into what was called the breaking out area. A place where the big bags of timber, the bales of timber, are broken into individual pieces of wood that can be run through the machine. They break out at the breaking out area. The timber was then moved to a pointing saw, moved to a router, moved to a planer. The people in the company had to actually write down the steps that they did to produce their product. very seldom do companies actually have the detail of what's involved. And this simple writing down on a piece of paper what's involved can be a very helpful step to a management team and a workforce as they try to improve their process. In all of these activities, we should be looking to see which of the actions add value, which of the work that our people are doing adds value. Are they doing things that they must do, but that they don't add any value to the process? Or are they doing things that they have always done that are not adding value as well? As the company continued to map out their process, they found many other things they had to do before they could make a door. They had to lift the parts had to be carried, they had to go to another machine, large parts had to go to a second router, parts went to the door making machine, to door cramping, door assembly, doors moved to sander, finished doors moved to dispatch. If we just think about these individual steps, it'll be clear to us that we are not talking about small movements. These are the big elements of the work of making the door. The company have not got into the detail of what an operator had to do to position the parts beside the machine, to pick up the individual parts, to position them into the machine, to set the machine, to start the machine, to watch the actual machine doing its job, to check the quality of the parts, to put them back onto the next place for movement, to move them to the next part of the process. You can see that there are many other parts of the process that have not yet been captured by the company. If you look at a high-level process map, it is usually very simple, and it is usually also very difficult to find waste at that level. But it is when you get down into the detail of looking at the detail that I have just described of small movements, small placements, setting up, changing, checking, that you begin to see lots and lots and lots of non-value added activity. The starting point has to be putting down on paper what is happening, how it is happening, and what you and your people are going to do to understand where the value is being added to your product and to your process. The starting point should be this high-level process map. It's usually best done by a senior person, a supervisor or a manager, because it gives the supervisor or the manager an overview of what is happening on the day-to-day in the business. When we start looking at the individual areas and the detail of any single process, that is best carried out by a team leader, a supervisor, or the person themselves, or the people who work with a person. Over many examples in industry, we have found that if one person is doing the job, his colleagues are best suited to help look at the process. The people he works with or she works with on a day-to-day basis are very well positioned to help look at the job. A practical example of how this has been done over many times: a manager with a support person, maybe an expert from outside, maybe somebody from within inside the company, would go to, say, the door cramping area. They would talk to the people who are doing that piece of work. They might engage with the people who are working upstream of that person and downstream of that person, and explain to them that they will look at the piece of work today to understand how that work is being done. As the worker does the work, the colleagues, the team leader, the supervisor, the manager will look and observe, and will create a page just for door cramping. And we'll look at the individual pick and place actions, the individual movements, the getting of materials. We'll actually write down what is done by the worker to produce the product. A trick, an insight that has been gained over many years, is that before any analysis is done of the written down process map, a lot of benefit has been gained and can be gained by just bringing that small group together for a few minutes to talk about what they felt, what they believed themselves they saw was happening, what they believed themselves they thought was good or bad, was value-adding or non-value-adding. And in that small discussion taking place at the place of work, it helps to do many things. It helps to build teamwork, because it becomes clear to everybody involved that there is a group of people who are interested in this job. There are a group of people who are interested in achieving improvements in this job. That the result does not depend on the worker themselves or the manager themselves, but it depends upon the efforts of the full team to look, to discuss, to think, to try to improve the process. So it helps improve teamwork. It also helps improve competitiveness, because by bringing those minds together and thinking about what has been done, it provides an opportunity to identify things that are not value-adding. It provides an opportunity to identify opportunities for improvement. It provides and sets an expectation that everybody will be involved in the improvement process. So a very simple exercise of capturing the overall process map can then be developed into looking at the detailed process map for each of the manufacturing steps, and in turn can be used very easily to build teamwork and the efficiency and the effectiveness of the business, building the capacity and the competitiveness of the business going forward. Physical flow mapping. We've talked about process flow mapping, which puts down the steps and the stages of the assembly, the manufacturing, the process steps. The second part of that is to look carefully at the physical movements and the flows that take place in an operation. We talked earlier about the principles of good practice of lean as being time, money, and effort. You can now see that the process flow mapping and the physical flow mapping are looking to see how long does a piece of work take, where are the wastes or the defects taking place, but most importantly, where is the effort being used to produce the product, to do the work. The physical flow deals very much with the how. How are you doing it? Where does the material or the information go? What is the actual movement of people, of raw materials, of finished goods, of information, of paperwork? I use the point about paperwork specifically. We believe a lot of benefit can be made by looking at the flow of paperwork within an administrative function, between the sales and the order placement, between the accounts and the customer. So it's as important to look at material flow and paperwork in the office areas as it is as components and raw materials on the manufacturing floor. We use a special term to describe the diagram that we produce using physical flow. We call it the spaghetti diagram. Why do we call it spaghetti diagram? We will start with a basic sketch of a factory, of an office, and we will then use a different colour pencil, pen, marker to draw on the physical flows of material and information on top of the layout of the business. And the funny thing that we have noticed over many years, doing this with many companies in many different sectors, is that after 1 or 2 minutes, the page looks like a plate of spaghetti. There is movement everywhere. There are lines backwards and forwards and up and down. Unfortunately, each of those movements costs money. Each of those movements costs time. And certainly each of those movements take effort. As a simple example, we are back in our door and window maker. On the right, we have our timber store. The wood was stored in this area, a small warehouse, in bales of timber, blocks of timber, strapped together with steel banding. When a door was to be made, the warehouse would take a piece of timber and move it over to the manufacturing area, either for a door or for a window. The layout looks very simple. We have a door manufacturing area, we have a window manufacturing area, and also we have a precision joinery area where special work was done by the business. It looks very simple, it looks very straightforward. Each of the blue areas represent machines in the process. This is the door manufacturing, this is the window manufacturing, this is the precision. So the factory looks very simple. The timber warehouse is out here. It looks like a very simple operation. If we now look at the operation with the movements of wood through the factory, we see a different picture altogether. No longer is it simple. No longer is it clear and obvious. Each of these lines represent movement of material or components through the factory. If we look at the door manufacture itself, the wood is transferred from the timber store to the breakout area, the router, through planing machines, over to a joining machine, the door machine, cramping area, into a planer sander, and out to the customer. But immediately you can see that it looks complicated. Materials are crossing over each other. If you now look at the window manufacture, from the store to the window area, over to the sander, back to the planer, out to the customer. This is grossly simplified for this exercise. The precision also needs to go to the planer, to the sander, before going out to the customer. What you can see is there is a lot of conflict. There is a lot of movement of material through the business. At each and every one of these movements, you will also usually find that there is a small storage area where material is stored until it is ready to be moved to the next step in the process. In actual fact, that adds additional time because the material has to sit waiting to be moved to the next area. It adds additional cost because time is equal to money. If the wood is sitting there, not yet made into a door, very few customers want the components of a door, they want a door. They're not prepared to pay you for the material sitting in your factory. And obviously, every movement requires somebody to move it. So there is effort involved. More and more effort is involved to move the materials through the facility. If we start with the process map and now look at the physical flow, we begin to see opportunities. One of the measures that we use in a very gentle way to help companies understand this is we actually measure how many meters, how many feet does a material have to travel before it gets through the full manufacturing process. How many feet, how many meters does a piece of paperwork have to travel before it gets through an environment? An additional trick that we use would be to look and see where the value is concentrated in this facility. When this particular company looked at their process and their physical flows, they saw opportunities to remove waste, to remove the waste of waiting, of transportation, to bring machines closer together, to organize their factory differently. They decided they could and would benefit from changing how they organized their factory. They used the basics of Lean to understand what the tools were. In this diagram, it's the same factory, the same footprint, but it's organized differently. You can see a door was put through the wall from the timber store to allow the timber to be brought in directly to the breakout area, which was repositioned Beforehand, it was up in this area. They decided to move it into this area, where the material could be broken out for the windows and the doors with minimum effort. They rearranged the door making machine that used to be here into a specific area. And now you can see the flows and the movements of parts and components is much simpler and much closer, which in turn means that less effort is involved to manufacture the products. They separated the doors from the windows and allowed them to be able to achieve efficiencies in their operation, which helped them to improve their capacity and also then to improve their profitability. I hope you can see a significant difference in the amount of spaghetti that is obvious in this flow, in this version of the factory, than in the previous version. If you were to work out the meters, the foot distance that materials had to travel in the business, you would see it is much less in this improved process flow than it was in the original. To start documenting processes. Many of our businesses have many different processes. So the first thing we must do is to select which of the processes are relevant or important enough for us to prioritize them. We need to be careful that we select the processes carefully. Otherwise, we will spend time on processes that are not as important as maybe could give us the best benefit for our business. So think about which processes contribute significantly to your turnover. Are there processes that are central to what you do? When you've selected the process, the first step is to define the process. We make doors. Oh, well, what are the steps and stages to make a door? We have seen how to create the process steps. We must now say making doors is a significant process for us. That's why we have selected it. We are going to look at making doors first before we look at making windows. So we define which of the processes we are going to look at so that our people have clarity and can see where they will put their effort and their energy. List in detail the process steps. From our experience internationally, what we have seen is that most people do not list the detail in their process mapping. I work with companies at many different levels, and I most recently worked with a large group of companies who were quite significant businesses. And we were working on an exercise, a training exercise with these companies from about 10, 15 different companies from different countries. And they were looking at a very simple process, a teaching process we use making Lego bricks. And we asked the managers to write down the process steps. And what they wrote down was very simple. They wrote down, get the parts, put them together, deliver the finished product. And we said, yes, you're right. That is what is happening here. But please explain to us now how that level of detail in your process map can be used to help you improve this process. They said, we don't understand. Exactly. If you say simply, get the parts, put them together, deliver them, you're right. That's what you're doing. But it does not give you enough detail to help you to see the wastes within the process so that you can find a way to remove the wastes, improve your capacity, and improve your value adding and your value retention, your profitability. So it's important, firstly, to get an overview of the process, certainly, but very important to go into the detail. And the Japanese have a word they call gemba, go to the gemba, go to the place where something is happening. And to be honest, you must go to the gemba. You must go to the door manufacturing space, to the place where the products and the materials are being made and used to see exactly what is going on, so that you can create detail of the process steps. Use the layout flow diagram. If you have the detail written down of the steps, it's obvious now that it's possible to create the flow diagram, the spaghetti diagram, that works in conjunction with the process steps. You will have the process flow diagram and the layout flow diagram. With both of these tools, you have the opportunity to identify the wastes, to understand the effort, and to look at the work content and the value-adding content that your people are doing. Both work very well together and are simple tools and techniques to help you to understand and to see. In a professional layout flow diagram, there are certain standard symbols to be used to describe different activities, from stop and start, transportation, decision points, yes, no, go, no go, inspection points, operation points, delay points, documents, storage, commentary, direction of flow, information transmission, and connectors, where large processes might connect into other process maps as well. These symbols can help you to create a straightforward process flow diagram. The level of detail you choose to engage with is up to yourself, but the primary process and the reason for doing the process flow is to make it possible for you and your people to see the flow through your business. When you have completed your process flow and your physical flow, whether you do it in great detail, whether you use the professional symbols or not, you will be looking for certain things. You will be looking to identify where queues are taking place, where material is waiting, where it is not being physically worked on. You'll be looking for waiting time, where you're waiting for a person, you're waiting for a machine, you're waiting for a material or a component. You'll be looking to identify where delays are taking place, looking to see, can the product move smoothly through your facility? Because the least amount of effort is when a part or a component moves through your business with the least amount of delay. It should be interesting to you to look and see, is it possible to create an opportunity where activities can happen in parallel? Is it possible for two things to happen at the same time? As companies develop their ability to improve, they begin to improve the equipment and the machinery that they have, and they may find ways to be able to bring two pieces of equipment or machinery together. This may be as simple as adding a drill to a clamping machine. There are many, many different ways that it's possible to look and see, is it possible for one setup, one placement of a part or component in a holder, that many things can happen to it, that multiple activities can be done at the same time. It's possible now that we have the physical flows and the process flow to ask ourselves, could we change the sequence? Would it reduce the time or the movement if we changed the sequence? If you remember back to the first diagram of the spaghetti diagram, you would have seen that some parts and components were moving to the left and to the right, up and down, backwards and forwards in the business, purely because a particular piece of equipment was positioned in a particular place. By thinking again critically about the sequence of the manufacturing and the assembly process, it was possible to remove and reduce the movement, the transportation. If you take the point that was made about the meters and the distance being travelled in a factory, and were to multiply the distance by the kilos, the weight of the material being moved, you could begin to realise that you are moving a lot of weight, a lot of distance over a year. It's often very difficult for us to see that because typically pieces are moved in small quantities, one at a time, a small number at a time. It may weigh several kilos, but does not weigh many tons. But if that several kilo part is moved thousands of times over the year, we get into moving hundreds of kilos, thousands of kilos. And that takes effort and time and energy. And we're trying to find ways by reorganizing our operations, our facilities, our processes to minimize that transportation cost. To help you improve the capacity and the competitiveness of your operation, consider applying time deadlines to your operation. We now have the process flow. We know how long things take to happen. We know the physical flow. We may have found ways to reduce the movements and the transportation. We now move to the point of being able to say, this piece of work should take X amount of time. It becomes possible to organize our operations and our people and their effort into time slots. Look at your paperwork. Look at what is required to get a product from start to finish. In many, many cases, we have seen examples right across the world where people produce large amounts of paper and paperwork documentation to produce a single item. It has been frightening in many cases to see the pure quantity of paperwork involved to produce a standard product, where in actual fact that same product will be produced the next day or the next week again, and the same level of paperwork will be produced again to produce it. I know nobody who is interested in the paperwork that it takes you in your business to produce their product. They are only interested in your product. So it's important to find and to look and to see, is it possible to reduce the paperwork? Ask yourself and your team, is it possible to standardize processes? Is it possible to develop a process to a point where everybody knows how it works simply, it works well, it works repeatably, and it allows you not to have to worry about that process. To find ways to do things in a simple way, so that new staff can be trained quickly and well, to mean that you can produce your product for your customer in a standard way. We talked about looking at the possibilities of relocating, combining compatible activities. More and more as expertise evolves and develops, the opportunity to do this becomes possible. It's building the capacity of your people to be able to look at your processes and to be able to be creative and innovative in how things are done. It becomes important if you look at the process map and the value. Each time you would move a part into a new machine or a new process, you have to position it correctly, you have to hold it correctly, you have to do the work on it and then remove it from that process or from that machine. If we can locate the part once and do several activities to it, we actually find a way to be competitive and active. I mentioned earlier the difference between the known process and the actual process. This is an actual example from a company I worked with many years ago. On the left-hand side was the known process. Put on the eyelet, rivet, bootlace. On the right-hand side were many, many different elements that were required for the worker to do that job. If the manager only knew the elements on the left-hand side, how could he possibly help his team to improve the process by tackling some of the issues on the right? We must look and know the actual and not the perception of what we believe is happening. We're back to a small example. This is an example of an assembly operation for a small electrical product. It was an extension lead for electricity, for putting many plugs into an extension lead. We see here 20% of the floor was given to work in progress. It was 15 days worth of work in progress sitting on the shop floor. And there were 12 people working in this process. But it looks quite clear. There's people, they're doing work, they're doing their job. If we put on the physical movements that took place through this facility, which are represented by the red lines, we will see material goes from the moulder to the work in progress, from the moulding work in progress to another holding area, a work in progress area, goes down past the assembly area to a test, comes back up to other assemblers, come down to cabling, comes over to pack, goes into a pallet and is ready to go to shipping. I would draw your attention to this one person here though. Their whole job was to clean the product. When the product left the moulding, it was clean, perfectly clean. But by the time it had gone through all the steps and movements of this manufacturing facility, it had to be cleaned before it could be sold. The company decided to look at how they were organising and how they decided to organise their operation. They decided not to hold 15 days worth of stock. They held a very small amount of work in progress. It's all the same steps to make the product, but you will notice they have reorganised. The packing and palleting is now over here as opposed to being here. They have decided to move the work in progress that used to be here down to here, and they have looked at the movement through the plant and the facility. They have gone from 12 people to 10 people. They have looked carefully at what they are doing, but we still cannot see the physical movements. If we now put on the spaghetti on top of this, we will see that there is significantly less movement, significantly less spaghetti on the diagram, because they have found ways to reduce the movements, the transportation, the picking, the placing, the handling within this operation. You might think now that they have finished, that they have found the best way. And at the time, they had taken some time to say, we have found a very good way. We have improved significantly. We have reduced our time. We have found ways to be better. But they didn't stop there, because they went back again and asked themselves again, have we found the absolute best way to make our product? Why do we still have to clean the product? Because we're moving it backwards and forwards on conveyors. That's why. They began to ask themselves what was going wrong, where was their effort being used, where was their energy being used, where was the time and the money being used. They began to ask themselves, were there better ways of doing different parts of the assembly process? They asked themselves, why are we screwing things together? They asked themselves fundamental basic questions about what they were doing and how they were doing it, even though they had already achieved significant savings. The third step looks very similar. Very similar but different. The screwers are gone. The people who are assembling and screwing the buzz bars are gone. Oh, what's happened? Well, we have a person now who is running the moulding machine, but also able to put in the assembly of the buzz bars. We now have a heat staker as opposed to people who are screwing in the components. They found an answer, a technological answer, a machine that would save them having to screw manually screws into the plastic. That helped them to not have to go up and down the conveyor as many times, which meant that the parts did not get dirty, which meant they did not have to clean them, which in turn meant that the customer actually got a new, clean product every time. In this simple example, you will see once again the spaghetti is reduced. But I hope you would also see and be critical of the spaghetti that still exists, the distance that still exists. And if it was you and your operation, I would hope you would be asking, what is this distance for? Why did these people not all move closer to the heat staker? Why did they not look critically at that last piece to see, can we find a better way to reduce the distances being travelled by our product within our manufacturing process, to reduce the time, the money and the effort involved to make their process? In this simple example, I hope you have seen the use of the process steps, the physical flow, but also, most importantly, that people are taking the first, second, third and further steps to improve their process, using process and physical flow to achieve competitiveness. Thank you very much.